Dr. Keary Howard. Keary Howard is an associate professor at the State University of New York at Fredonia, which is where I did my undergraduate and master's work. He is also a graduate of Cornell University, the associate editor of the New York State Math Teachers Journal, and last year's recipient of the Chancellor's Award for Excellence in University Teaching. And today he's here to talk to us about implementing an integrated curriculum.
Well, thanks very much. I certainly appreciate all the undergraduates who are within just a few months of beginning their careers as what I call cash money teachers. And I told you guys earlier when I had a chance to spend some time with you that you are in a program that is world-renowned. And you've made a wonderful decision to come to the University of Georgia. I did bring a little rain with me last night as best I could. I'm going to be heading back to New York after a football game. They tell me they play that down here, so I wanted to see that a little bit. I'll be heading back to probably between 6 and 10 inches of snow. There's a lake effect snow warning in my hometown. And it happens to be about 20-25 miles from where that picture is taken right there. Now, you see the cat on the left. That's Dana Ticroni. Raise your hands if you've had any interactions with that guy right there with a cow tie Omega shirt. I want to see who knows Dana. Okay. He's wearing some Greek letters. At SUNY Fredonia, we don't have a big fraternity system or sorority system, but Chi Tau Omega represents the founding members of our math club. And so when we go racing, that's sort of his lucky shirt. To his right, actually his left, are his pit crew, which happen to be Madigan. There's the first one. Cass is in the middle, and you always have to have a child with a cowboy name, and Campbell Joe is on the far right-hand side. Those are my 3 children. One of the highlights of their summer, for the last 3 summers, is to go racing with Dana Ticroni and the number 67 Project Prime SUNY Fredonia Racing Grand Prix. It has won 1 trophy and $50. Let me tell you a little bit about what I want to do today. I want to talk a little bit about integrated school mathematics, and I hear you guys are going that approach. Fortunately for you, I've been through this for about integrated math has been in the schools for about 30 years in New York State in one form or another. And I'll talk about some of the pitfalls you guys might see, certainly the products, and I want to make some predictions for you as well. If you need any of this information, please, there's my email address. Just simply zip me an email and I can give you the whole thing. Hey, we're going to start out like a real teacher today. I'm going to give you objectives. All right, here are the objectives for today. We have 60 minutes. Here's what we're going to accomplish. Number 1, I want to define a version of integrated mathematics with what I call a few good hooks. So we're going to do some math today. We're also going to do it so if you can solve some of these problems, I might give you cash. And some undergrads here, you guys can always use money, right? Yes. There might be some professors here who wouldn't mind doing something for 10, 20 bucks too.
We need money, yes.
All right. I'm going to put you in a New York state of mind by sharing with you some very specific examples of where integrated mathematics has gone well and where it hasn't gone so well. I also want to talk about the real Dana Ticroni. So we're going to visit integrated mathematics literally through the problems that taught him his mathematics when he was in 9th and 10th grade. I'm going to tell a fortune of what I think is mostly good for Georgia school mathematics. I'm all about making some predictions. And lastly, I want to get ready for some SEC football. So all those things are going to be accomplished in the next 60 minutes. Let's start this way. When we think about integrated mathematics, 3 things will come to mind. We're going to revisit this at the very end. If I think of an integrated math curriculum, I think of rich problems. All right, you guys are in a department that has been building rich problems and pushing you guys to think like real problem solvers for many, many years. And I want these rich problems to do 3 things. I want to prompt solutions between and within fundamental math content areas. All right, so I don't want to just do geometry. I want to combine, integrate amongst the content areas. I want to foster multiple representations. All right, I want you to be able to see mathematics, and we're going to talk about that in a second as well. And if you're going to come up with a problem, we talked about this in methods today, if you want to come up with a problem, you want to come up with problems that kids want to solve. right? You've got to engage in a way that makes mathematics meaningful for them. So let's do one. Are you ready? Here is a question. Don't tell me the solutions. I want an integer value on the number of solutions. This is a simple equation. 2 to the x equals x squared. Don't shout it out. I want you to think about it. 2 to the x equals x squared. Do I want the solutions? No, I want the number of solutions. I'm digging into my pocket here for a second. Hold on.
Teachers have to dig deep.
Come up with some cash on the table right here, Dan. I don't have much. Where's a $5 bill? I'm not going to give you the $5 for telling me the integer value in terms of the number of solutions. But I might give you the $5 bill if you can algebraically solve for all the solutions. But let's go back to the first question. Anybody here think they know how many solutions there are to that? 2 to the x equals x squared. Got one guy. Don't give it up yet. Come on, don't be. I got one guy says he thinks he's got the number of solutions. I'm going to call him. This is
Brian.
Brian, where are you from?
I'm from Atlanta, Georgia.
Atlanta, Georgia. What do you do for a living, Brian?
I solve math problems.
You solve math problems?
And help other people.
And help other people solve. That's very good. How many solutions do you think there are to that equation? 2 to the x equals x squared. Easy equation.
I think there's 2 solutions.
He thinks there's 2. Now let's push him a little bit further. Can you tell me the 2 solutions?
2 and 4.
All right, how did you get that, by the way? Because there's a lot of ways to solve equations. You would agree, right? A lot of ways to solve equations. How did you do it, Brian, from Atlanta, Georgia?
Well, to get 2, I just noticed the similarity between the 2
that's an interesting.
representations.
So you're telling me 2 squared equals 2 squared.
Yeah.
Also, 4 equals 4. So x equals deuce. All right. You got anything else?
And then I start thinking, okay, does that work for other powers of 2? Because
Right.
you have a power of 2 here, and you're going to need a power of 2 over there. So then the next one I tried was 4, and it worked out nicely.
I think it does. 2 to the 4th. What is 2 to the 4th? Another way to write? 16. Is that equal to 4 squared?
Yes.
Right, you're right. You almost got yourself some money. But is that, or are those all of the solutions to 2 to the x equals x squared? I got somebody in the back shaking their head.
Yes.
Some people say, hold it. I want you to know. Here's the integrated part. Here's the integrated part. I want you to see mathematics. Right? I want you to see mathematics. This is for everybody. If I said, when you see 2 to the x, what do you see? Tell me, what do you see? Give me the geometric representation. Y equals 2 to the x. What is it? Exponential.
Right.
Well, hold on. We're
2 to the x.
2 to the x.
Sorry.
2 to the x is exponential.
Exponential.
You everybody see it? Sort of starts down there in the second quadrant, works its way up. It's got an intercept somewhere. Let me think. 1. And then it keeps going up, right? When you see x squared, what do you see? A parabola. Basic, right? Just old school, basic parabola. Where's its root in this case?
0.
Now, if I set that 2 to the x equal to x squared, do they intersect just 2 times?
No.
Is there a third intersection?
Yes.
Look, see, Wilson had it over here. He just wasn't going to get it up.
It's on my webpage.
See? Jim Wilson's killing this.
And he's flunking now.
Yeah, I did think about the representation, but I forgot the 2 and 4 on the other side.
2 and 4 on the other side. Then you've got that 1 in that second quadrant. I'll give Jim Wilson $5 now so if he can algebraically solve it. By the way, if we told kids to solve this and they saw an exponent, what process would they typically use? When you solve for exponents, what do? Logarithms, first thing that comes to mind, right? Or if you solve for quadratics, what do you do for that? All right, so I'm sorry, if you're solving for something squared, you're going to use quadratic formula, something, any of those methods. I'll give Jim Wilson this $5 bill, and it's hard to get my money, Jim Wilson.
You go to my webpage, it's there.
What? Algebraically? Oh.
Using iteration.
iteration, which, by the way, is what a nice graphing calculator can do for you. Same process. All right. Does everybody see what I mean by integrated mathematics? Good problems, rich problems, make you see mathematics, whether it's through inspection or through visually seeing these two set equal to each other. Those are rich problems that allow you to integrate among content areas. I'll tell you a little bit about New York State. I said I was going to put you in New York State of mind. New York State is home to some of the largest school districts, the New York City School District, for example. Some of the smallest school districts. Clymer Central School graduates, on average, 36-ish students a year. And the richest, the Hamptons in Long Island. It's called the Empire State for a reason. If you drive from Clymer, New York, which is in the far southwest corner of New York State, and you were to drive to the Hamptons on Long Island, it is roughly the same in terms of driving time to the following two towns, from Clymer to Columbia, South Carolina, or from Clymer to Knoxville, Tennessee. Why would I put those two towns on this slide? I told you I was going to see some SEC football in there. Columbia's home to the Gamecocks, right? And the old ball coach. Knoxville, what's the cat over there? Fulmer? You all know. I heard you had some trouble with both these guys this year. I heard there was some Rocky Top being played and over and over. But if you were to drive from Dana's hometown to either of those two, it would be just about within an hour of what it would take to go from one end of New York State to the other. Since the 1950s, all school districts in New York State have been united by a common high school mathematics curriculum. Since the 20s, we've been given what we call Regents exams. And Regents exams are not simply an exam to get you out of high school or to get you as a way to graduate. Regents exams, for many years, were what your accelerated students would take. And again, throughout the entire state, it would be exams in chemistry, in physics, 2 or 3 in mathematics, English, social studies. There were these common assessments called Regents exams. So when No Child Left Behind came along, we were just like, look, we've been given state exams since the 20s. This is not going to be a big deal for us. An integrated math curriculum at the high school level was piloted sometime around 30 years ago. And there have been significant revisions over the last 2 occasions, but it still remains firmly in place, although under some modifications. I learned my mathematics in high school as it was being piloted in the early 80s in my home school district, and Dana learned his mathematics, school mathematics, under a similar curriculum. All right, quick riddle. Want you to rank order the following 3 artifacts for me, from greatest to least, on their influence on the taught curriculum. Let me define the taught curriculum. That's the stuff, if you're going to go out into schools today, sort of the day-to-day kind of stuff that gets taught regularly. All right? I'm going to give you 3 artifacts. You're going to tell me, in your mind, rank them from greatest to least in terms of their influence on what gets taught. 1, state standards document. You guys got one of those, and you'll continue to work on it. Textbooks, or state-mandated exit exams. And take a moment and think about it. Which of those 3 things, or you can rank them all for me if you will, have the greatest influence on what teachers teach on a day-to-day basis in school math, particularly at the high school level? All right. Lainey, are you here?
I am.
All right. What would be your number 1? What do you think would have the greatest influence?
Well, I'm wavering between B and C, but I'm actually gonna I think I'm gonna go.
Say C. Because you guys are about, now you have a history in Georgia of having some state mandated exit exams. That's true, right?
Yes.
Okay. See, all this has been ratcheted up with No Child Left Behind, and particularly as it gets to schools being evaluated, teachers being evaluated. In New York State, state-mandated exams have always sort of been the way to drive the curriculum in terms of what gets taught on a regular basis. And I'm wavering between A and B. Anybody think what might be second most important? Because I honestly God don't know. How do textbooks work for you here in Georgia? Does Houghton Mifflin or McGraw-Hill or any of those guys, do they make books specifically for Georgia math curriculum?
Yeah.
Or do they say they do, and when you go to your GCTN meetings, they all say they're made for, but in your heart of hearts, if we went to,
California.
right, it might be the same book.
It's not the same order.
Okay. And the state standard document, I think, is going to get a little more influence than you think, particularly if you implement correctly. And we're going to talk about that. All right. Oh, before we get to this, here's a little background picture for you. You can't really see it because I've lightened it up a little bit. Dana, do you know some of the people that are in that picture?
I know all of them.
You know all of those guys. Clymer, New York, again, graduated, what did I say, 36? Also is home to the smallest school district to actually house a varsity high school football team in New York State. These kids that you see right there were Dana's teammates, except they were on the JV or the modified team. Which was it? You don't even have a modified program, do you? When can you start playing football in Clymer?
9th grade. 9th
9th grade. So there is no midget program. So if you want to try out for the team, you got to try out in 9th grade. Did you try out in 9th grade?
Of course.
Where'd they put you at?
Left guard.
Left guard. At about 125 pounds. Okay. See, 125 pound left guard. Your senior year, which position did you play?
Tight end.
So you worked your way from left guard to tight end. Very good. Those are Dana's teammates, but he was already away at SUNY Fredonia doing his schoolwork when the kids that were JVs when he was in high school made their way to the state title. 39 in a graduating class. The one right there that's running the football is a senior at Michigan State, Jehu Coulter. So if you guys don't watch weekend football, so that doesn't make sense anyway. A couple of things. These guys are old school in their uniforms, as you can tell. And you can't really see it. Does it look like somebody's got their name on the back? Can you sort of see that off of number 23 at the top? Now, Clymer, do they put the kids' names on the back?
No.
What do they put on the back of that uniform?
Clymer.
That's all they put. That's the only thing you will get that's extra in a Clymer uniform is the name of the town on the back. Couple things. 9th, 11th grade mathematics takes on weird and blatantly non-descriptive names in course 1, 2, and 3, like course 1, 2, and 3. So when we've been doing integrated math over all these years, and you came to our state, you'd say, all right, I'm going to take algebra. And we're like, no, you're going to take course 1. And nobody in the rest of the country knows what course 1 is. Or if you didn't call it course 1, we'd call it sequential 1, sequential 2, sequential 3. So it was a real problem in terms of trying to name what it is. And I see you guys are sort of having the same problem. What are you guys going to call your 9th grade mathematics next year, do you know?
Math 1.
Oh, so you're just as good as us, Math 1. All right? Topics taught are expansive and often re-examined from year to year. In the 1990s, typical New York State freshmen and sophomores were exposed to, get this, all right? Logic, transformational geometry, combinatorics, as well as more traditional curriculum materials such as algebra and Euclidean geometry. I also forgot a couple of them. We were good at locus of points. Man, I could solve locus of points problems like it was my job. Truth tables, and you guys have no idea what I'm talking about in terms of truth tables. Right? We did a lot of discrete mathematics. Do you? Good. Can I tell you what I was bad at, though? Because this is a prediction. Here's what I was bad at. And Jim Wilson's going to hate me for this. When it came to Euclidean geometry and proofs associated with Euclidean geometry, we just did not have the time in the curriculum to do it. So it's a weakness. And remember, you guys are going to have to sacrifice something by going to an integrated math curriculum. Texts needed to be created specifically for New York State students since the curriculum was so different from other states. They varied from traditional and very progressive. And each school district was free to choose its text. And the decision often was in the hands of 1 or 2 people. In Clymer, how many math teachers were there at the high school level?
3.
Okay? So 3 people would make the decision. These Oh, by the way, we're good at this. This is the AMSCO book. This is one of the traditional ones, been around since the 1980s. You watch the Cosby Show, and every once in a while they'll have them bringing home textbooks. This is a book that comes through. So the book that was on the Cosby Show for New York City mathematics is the same one that Dana would have. And in fact, these come from Clymer High School. And in fact, same book that I had. I don't have the third year book. That was a lime green one, really. But you could tell how cool somebody was and how far they were on the curriculum just by the color of the book. All right. I'm going to send these around. Dana, you know the names of some of these people in this book?
Everyone.
Let's see what Dana put. The 10th year mathematics would have been the one that would have had more of the focus on geometry. I'll read you some of the things. Logic was an entire chapter. There was some triangle congruence in there, some quadrilaterals, special right triangles made it in there. Locus, with and without coordinate geometry. Probability, gotta have it. Operations with fractions. Mathematical systems. I could do clock arithmetic. Groups with finite sets. 10th grade math, right there for you. For all those. I'm going to send these around so you can take a look at them. More importantly, what did I say was driving this curriculum in terms of day-to-day operation? We're going to get to those. You want to see what goes on in New York State mathematics? It's easy. You just go on the web. You can find every one of these exit exams going way back. In fact, what I've done is I sort of did a little math, a little arithmetic, found out when Dana Ciccone was a freshman. Let's see some of the questions that he would have to take on his Regents exam. And remember, if you really believe that an integrated curriculum is about rich problems that combines content areas, this is important. Because often what happens in integrated mathematics is it becomes not a combination of items, but a unit here, a unit here, a unit here. It becomes what I call buffet style. So look at these are what we call part one problems. Some were multiple choice, some weren't, but they're all worth two points essentially. There's a little logic question for you. Oh, I like number 16. Because when we thought about integrate, we tried to get cute every once in a while. We're going to combine a little algebra with, what is it, the parallel puzzle, some transversals here, and some vertical angles, right? So how do we combine it? Well, we throw some variables in and say we've integrated math. There it is. It's done. You got your algebra and your geometry in one problem. How can you go wrong? You see how that's a little forced, though? Throw a little point symmetry. Always going to have that. We're going to graph some inequalities, some standard y-intercept questions in a multiple choice format. Do you see now how the curriculum becomes a bit disjointed, though? Right, some problems here, some problems there. Part twos look like this. All of these exams, and this is important, through about 2000, were traditional criterion reference exams, and I sort of like that. Criterion reference exams, like, how do you guys get a license here in Georgia? You got to take the driver's license. You take a permit test first. Do you have to get a certain % on the permit test? You remember what it was?
You can only miss 5.
You can only miss 5? See, I was like that too. I was that one kid that when it came time to take the driver's permit stuff, I went, because other people were, I was a little younger, so other people had taken a test, I would grab their old test. They'd allow you to take the test home. So instead of reading the entire book, what would I do? Take everybody's old test. You know, that's just this is the system I was raised in. So I took everybody's old test, right? Found out what was going on. Passed it. That's a criterion-based test. It says if you get above 80%, you will pass. That's the way these exams work. These are notice here, they'll break the points down for you. 8 and 2. Oh, remember what we said about being able to solve things multiple ways and getting credit for it? Check this one out. We're going to solve this algebraic system of equations. But they're only going to allow me to do it algebraically. That's all I get points for. So if I'm going to try any other methods, I'm out. They won't even let me do it. By the way, it's integrated, so what's that mean? We've got to have buffet. So what's going to be in our buffet? We need a little frequency. We'll throw a little stats in there, keep people on their toes. What else? Here, we got a classic integer problem. Now we're going to graph some inequalities. 9th grade materials, what the focus was. I'll talk, just 2 minutes on curriculum theory and implementation. A guy by the name of George Posner was a big influence on me during my graduate days. He's a science educator, did a lot of his work in conceptual change, but he was very good at looking at curriculum and made an awful lot of great decisions on if curriculum would work or not. And specifically the operational curriculum is what we're talking about here. And this is important for all you future teachers, all right? If you're a teacher, these are 4 things that you're going to have to do on a day-to-day basis. You're going to have to cover some material. You're also in your classroom going to have to provide some mastery, or at least have your students provide some mastery for you. You're also going to have to manage the classroom. You've been there and done this. You know what I'm saying, right? Okay? And while doing all of this, you're going to have to foster in your students an opportunity for them to develop an appreciation for mathematics. We call it a positive affect, right? We want them, they may not all want to get up in school and be in your room every day, right? So part of your job as the teacher is to foster that appreciation. Notice what Posner says. He says teachers will adapt or transform any and unsuitable curriculum in such a way that they can make the curriculum fit classroom realities. Okay, so I'm going to tell you, you might have a great document at the GCTM level or at a level that we've got the Georgia standards. But if it doesn't fit the classroom realities of what's going on in Georgia classrooms, it's going to get changed. Okay, so that's a bit of a warning. So, Dana takes his exams in the late 90s. We get to 2000. In 2000, big upheaval. We've got No Child Left Behind coming down the pike. We've got the new standards, right, from NCTM. And we've got integrated math trying to change a little bit because they were in this very sort of structured buffet style system. I say it ends up being a bad date. And what did I promise you undergraduate? I said I'm going to give you the greatest what? Before you leave today, you're going to get the greatest breakup line of all time. Let me tell you about the bad date first of all. The last decade, critical change in New York State. We decided instead of doing every exit exam in June, which makes sense, right? Done in June, give them an exit exam, see if they at least can give you the criteria in terms of what they know about the mathematics. We decide we're going to shortchange them. We decide we're going to go a year and a half and give what we call the Math A exam. And while we're trying to raise bars, we're going to require everybody in New York State to pass the Math A exam, which will take you a full year and a half into the curriculum. Everybody. If you want a degree, you're going to have to pass the Math A exam. 3 critical changes were made. Standards were raised, requiring everybody to pass. The exams moved from, now be careful, we went from this very base criteria where everybody knew what was on the exam and what we had to teach to a norm referenced exam. All right, now think about it. So now an 85 doesn't mean an 85 anymore. We go norm reference and we eliminate choice. And remember, we also want to sort of think about the standards. We wanted to provide some more problems that would allow students to do more constructive response and to try and solve problems in a little bit deeper way. This sort of conspired against us. Okay. Greatest breakup line ever. I told you it was a bad day. If you get a chance, this is the greatest breakup line of all time. You must save this for the appropriate time. Somebody has done you wrong. Promise me, once you can use this in your life. Take the L out of lover, because that's what we are. Think about it. Take the L out of lover, because that's what we are. Nick, tell me, what is it?
It's over, baby.
It's over! Come on, once! Gotta save that. Trey? Because that's what happened. We made all those changes in New York State, and it sort of bit us in the rear end. Let me show you. June of 2003, Math A Regents exam produced the greatest uproar of any New York State exam to date. We had started giving this exam, there had been about 3 or 4 iterations of it, without a whole lot of control from outside influences. Teachers, by the way, in New York State are responsible for the 9th, 10th, 11th grade exams, which I think is a good thing. At the middle school and elementary level, they're made by McGraw-Hill, and that to me is a concern. 2/3 of the students failed the exam, many of whom planned to graduate. 2/3 failed the exam. On the earlier course 1 exams that Dana took, the exam was maybe 30, 35 questions, you do 30, and then the part 2s were 4 of 6 kind of thing. 3 hours to take it, done. Usually a 4-page packet, and that was the exam. By the time we had gotten to this 2003 exam, the packet was well over 20 pages. And you had 3 hours to do it. And you were under some pressure. Can you understand that as people just kept flipping to the next problem, to the next problem, to the next problem, it felt hopeless. The exam was poorly written, verbose, and perhaps overly difficult. I'll give you a couple samples in a second. Within a few days, the commissioner of the state ed department in New York voided the entire exam and established a panel to see if they could solve the problem. The best thing that came out of the worst exam ever is that we had a chance to revisit the way we teach mathematics in New York State. And I think we're doing it much better this time around. In particular, like you guys have done, we have created performance indicators all the way from kindergarten to grade 12. So that if you're teaching 2nd grade or 3rd grade in New York State, you can go to this and you can see this is what we would like you to teach specifically in terms of the mathematics at grades 2 or grades 3, and certainly grades 9, 10, 11, and 12. We call those performance indicators, and it helps our teachers know precisely what it is that we're trying to do mathematically at that grade level. Let me show you some of the problems on the worst exam ever. Remember, you'll be taking this, you could be anywhere between 9th grade and 12th grade. Can you imagine, again, graduation resting on the results of something? This is question number 26. Seth has one less than twice the number of compact discs that Jason has. Raul has 53 more CDs than Jason has. If Seth gives Jason 25 CDs, Seth and Jason will have the same number of CDs. How many CDs did each of the 3 boys have to begin with? You'd have to give me 25, 30 minutes. I'm still not sure I could get the problem right. Okay? Then we start throwing this on there. We try to get cute. A straw is placed into a rectangular box that is 3 by 4 by 8. They give us a picture. If the straw fits exactly into the box diagonally from the bottom left corner to the top right, how long is the straw? Now, do you know what kids are doing in this case? They say 3, 4. What do you know what they're doing? What are they going to put in as the answer? 5, right? Again, by the way, this is problem 34 now. So you're tired. So you see 3, 4. You've been taught the Pythagorean theorem like it's your job. So what do you put in? 5. Is 5 the answer they want? No. Do you see that it's going from here down to here, right? So the 5 is going to get you to there. So now what do you got to do? 5. Now you got a 5 on the base. The 8's going back up. Tricky, right? Or poorly written, I'm not sure. Got a honey-do list for Georgia's best math educators. These are some things I think you're doing or could do that are going to make things work for you. I want you to work hard to establish a set of math-specific standards and content performance indicators. And you've done that. I bet I'm right. We shared a couple of weeks ago, right?
Right.
Okay.
I mean, I didn't do it.
No, but they're out there, right?
They're out there.
And tell me this. They're right now, they've already revamped 7th and 8th grade. They're teaching the new curriculum for 7th and 8th grade. Yes. And when is algebra? Well, it's not algebra. It's called Math 1. All right, so do create statewide curriculum material that can be used in the creation of Georgia-specific text. And I was looking at Dana today. There's some great problems out there on this standards website. Some really good stuff. Do entrust your teachers with the creation of high-quality exit exams. Now, this is important. That accurately reflect your curricular content and philosophy.